Shh. Hello, ninth graders.
Hello, Mr. Berryman.
How you guys doing today?
I'm tired.
Tired? You guys just had lunch. You should be awake.
Yeah, but yesterday sucked.
I'm sorry.
The teacher in math class was
What'd you guys eat for lunch?
terrible. Pizza.
I had a bagel.
I had French fries. I had a sandwich with a brownie.
You have brownie?
I'm glad you guys all have that rock solid memory because we're gonna need that today. We're learning a lot of new stuff, but it's not gonna be too bad. You guys already know most of this. You're just gonna have to keep up. Think you guys can do that?
Yes,
Probably.
Okay. Who read my objectives yesterday? Was it Tyler and John? All right. Connor, you want to read the first one for me?
I will be able to estimate a graph line based on a function.
Good job. We all get what that means.
I will by the end of class.
You should already know what that means, actually.
Oh,
But we already know that.
I was kind of
I learned
lost
about it
yesterday.
yesterday.
We're gonna learn more about it today.
Oh, okay.
So you weren't super far off, Tyler. Alex, you want to read the next one for me?
I will be able to look at a graph and estimate what the function will look like.
Do you know what that one means?
That we'll be able to look at the equation and look at the graph and know what it's going to be.
Exactly. So something like I'd give you a graph, and you would be able to know that it's.
And then
Excuse me. Well, no, you'd be able to know. Actually, we're gonna do it right now. So I'm gonna draw a graph for you guys. Ooh, I missed that point a little bit. My bad. And you guys are gonna try to figure out what the equation might look like. Okay? That sound good?
Okay.
Y equals 2x plus 1?
Talk at your tables, actually.
Oh. I think it might be y equals 2x plus 1.
So the plus, so you know how the mx plus b? So the b is where it crosses the y,
Yeah.
the y-intercept.
Yeah.
And so there, it crosses y1. And then, so what I was taught was rise over run. And so right here it goes up 2 and over 1, which means 2 divided by 1 is 2. And so that's the m. And then x is the number you can change, because whatever you change x to will change y. Okay.
Guys got it?
I think so.
Tyler, you sounded like you knew exactly what I was looking for. You want to tell me what you said?
Check
What you
this
told
out.
your group?
Yo.
So, what I concluded was, so it's an mx plus b function.
Okay.
And so the b part of it is the y-intercept, and so that's at 1, so which makes it the plus 1 at the end.
Okay.
And then, so I was taught rise over run last year, and
Yes.
so what that is you go, it's the number that it goes up or down divided by the number that it goes left or right. And
Okay.
so for this one, it goes up 2 over 1 to the next point, and 2 divided by 1 is 2. So that's the m, and so if you put those all together and keep in the x and y variables, you have y equals 2x plus
So
1.
like that?
Yep.
That is exactly right. Good job, guys. Well, good job, Tyler. I hope you guys helped.
Yeah, no, we just told them what to say.
I got you. And that'll happen. Sometimes it takes somebody else saying the words out loud to understand it. So, that's all right. Don't worry about it. So, Tyler's exactly right. When you change the magnitude of something, which is when you add to the x, it changes how sharp the angle is, right? And then when you change the y-intercept, which is the b, it changes where the graph intercepts. Let's try another one. See if Tyler can figure this one out.
Are there graphs that never intercept, Mr. Berryman?
Yep. Yeah, let me show you a quick one really quick. So there's a function called natural log. You won't learn about that for a few years, but that function looks like this. So it gets infinitely close to the x and y axis without ever actually touching. So that one's kind of cool. It's one of my favorite parent functions, which we learned about yesterday. So you guys, that should look kind of familiar. Again, it was just our first day talking about it, so don't worry about it too much, but that's what that is. Let's see if you guys can figure out what this graph's equation might be. So talk amongst yourselves, see if you can figure it out. This point is 2-1, by the way.
Put it in absolutes. I don't know if we've learned absolutes.
Hey, have we learned absolutes, Mr. Berryman?
You learn absolutes?
Okay.
Put it in absolutes. Wait, I don't know. I just know that it never goes negative.
There's your
Oh, is
hint.
that how that works? Oh, it is x squared. You are on the board. We don't, I don't think it has to be an absolute if it's squared.
Well, because if it was squared, we just
The one and the two.
yeah, I don't know.
You guys want me to help you out? Look like you might be struggling a little bit over there.
Yeah.
Yeah.
So Tyler, what idea did you have? I heard you saying it a few times.
Well, since the y never goes negative, I said to make it an absolute. And so you
Absolute
put it in
value.
the lines, and so it never goes negative.
So, draw another graph over here. We learned yesterday that the absolute value graph, it kind of does look like that. So that's what the absolute value of x looks like. So, it does look similar. Looks like it's got a little more hook to it though, right? So does this maybe look more like our quadratic equation? Looks a little bit more like it, yeah?
Mm-hmm.
So, Tyler, how did you know that the previous graph we had, the linear one, was shifted up along the y-axis?
Because where it crossed,
Okay, so where does this one cross the y-axis?
probably somewhere between 2 and 3
So what if we pretended that it wasn't moved out to the side, where would it intercept?
at 2.
Right. So what do we do to the linear equation to make it 2?
Just plus 2.
Yep. So for quadratic equations, it's the exact same. Whatever the b value is, you just throw in there. This part's a little more tricky, and I kind of misled you, which was on purpose, because I wanted you guys to think a little more critically. But quadratic equations, when you manipulate them, which is what we're doing, manipulating functions, it looks a little bit different. So what that's going to look like, I'm just going to do the whole thing, actually. So this is over 1. So this is going to look counterintuitive, but don't panic, okay?
I'm scared.
Why does that look weird?
Wait, why is it a minus if it goes to the right?
Exactly. So, think of it this way. You guys all take out your calculators and type in x squared or x minus 1 squared. Show you guys up here. So do you guys see how it's moved like that?
Mm-hmm.
Okay, and did you guys happen to see what I typed in for the equation?
No.
There should be a light on there. Oh, let's lighten up a little bit. So like that, right? So that's my equation, just like I said. Just like we drew on the board, right?
Mm-hmm.
So the reason for that is if we take x, whatever it is, minus 1, it's actually going to be moved to the right because, let's say we take x equals 2. So what's 2 minus 1?
1.
And what's 1 squared?
1.
Plus 2.
3.
So that's why if we take 2, that's why it's further to the right. So everything shifted the opposite of what you think. So if we had x plus 1, for example, it'd be the same thing. It'd be shifted to the left instead of the right. So, whatever this is, the easy way to remember it, regardless of how it works, is it's just the opposite of what we think it is, okay? So, that's pretty much how we're going to manipulate functions. We can also throw, this one's minor, but it's kind of hard to see with the naked eye. We can also throw a magnitude onto the x without actually affecting the x. If we put like a 3 in front of it, and that'll make it so it's sharper. So if we had a number less than 1, or between 0 and 1, it'll be wider. And if we had a number more than 1, it'll be sharper. Can anyone guess what would happen if I put a negative number in front of it?
Flip upside down.
Yes, it would. Good job. Alright. I should have taken that down because I still need it. So I got a couple questions for you guys. Really quick. This is your exit ticket. So if you guys can answer these questions, turn them into me as you leave, you guys will be all good to go on to your next class. Take a couple minutes to do that. You guys can work together if you need it.
Who are the Warriors? It's a movie? I don't know
That
the-
is a bonus
I don't know
question.
the
You
actors.
will get bonus points if you can get it right.
I don't know the actors in that movie.
It's not actors, you can do character names.
Is Will Smith in that?
Yes.
It's Denzel.
Oh, it's Denzel. Okay, no, but the first one Joe Jackson, the first one. He said
Hmm?
so the first one should go to the left, right?
No, it'd go to the right. It's minus one goes to the right.
Oh.
Plus one goes to the left.
Oh, okay.
All right, and instead of turning this in, we're just gonna go over these together. Who wants to answer number 1 for me? Alex.
It goes to the right.
Yes, because it's opposite, right? We learned that today.
It's
Alright.
opposite day.
Tyler, you want to do number 2?
Sure.
Just draw in the air.
So you get your thing,
Yeah.
and so like here's the thing, and then you go up +6, and you sort of, from your perspective, go like this.
Right. Exactly. All right, John, you want to air draw number 3 for me?
Yeah, so you have your axis, and then you go up 6, and then you make your x squared.
Yes, and it's still facing up, right? Because
Yes.
it's a positive number. All right, Connor, who's your favorite member of the Warriors?
He said Denzel's in the movie.
Denzel.
The answer is always Ajax. Always.
Why, Mr. Barry?
Because he's the best character. It's obvious.
Why?
Isn't that an opinion?
Yes.
Mr. Merriman,
Yes.
in the show, who's the boss? Who's the boss?
I can't say that. It's for my time, man. But you guys did excellent today. Again, keep these learning targets in mind. We're going to touch on them a little bit tomorrow. Tomorrow we're going to learn how to make those functions ourselves rather than having you guys watch me do it. So good job, and you guys are all good to go.